Hey everyone, this is Avinash. Back with another video. In this video, let's talk about LLM, NLP and how they work, right? So let me quickly share the screen with you all. Yeah, I hope you all can see the screen. So firstly, LLM. As everyone know, LLM stands for Large Language Model. And the reason we call it as a LLM, not AI model, despite it is just an AI model, we just call it as Large Language Model for two reasons. Number one is it was fed with very large amount of data. It's an AI model, but this time this model was fed with super high large amount of data. That's number one. Number two, this massive amount of data is fed to generate very human-like language and text. So that's the very reason why we call this AI model as a large language model. It refers to a type of artificial intelligence that uses massive amount of data to generate human-like language and text, right? So think of it as a algorithm. Into this algorithm, we feed super massive amount of data just so that this algorithm could process all the information, figure out patterns and make those patterns into parameters and use those parameters to kind of understand what humans are talking, so that whenever humans ask some question, it from its knowledge base, it could answer all of the humans' answers. So that's the very reason why we invented large language models. And they are all commonly used in applications such as chatbots, language translations, content creation, and whatnot. We're using so many large language models ourselves these days, like Google Bard, Anthropic, Cloud 2, and we are also using ChatGPT, the most famous large language model in the world right now. So yeah, these are the few examples of large language models and how large language models work. Necessarily, it just works like any other AI model, which has foundation model in between. Into this foundation model, we take any kind of data. Sometimes you take only one type of data, and sometimes you take different types of data. Like the data format can be in the text, images, speech. It can be structured data. It can be 3D signals, etc. So we take all this data and feed this to foundation model. And to this foundation model will understand and figure out patterns from the data humans give in this training process. Once they find out patterns, they observe the patterns and make those patterns as parameters or rules that they needs to kind of, parameters are nothing but the conclusions from all the observations foundation model did. Using these conclusions, this foundation models will be adapted to do all those human tasks like question answering, sentimental analysis, information extraction, image captioning, object recognition, etc. Right? So that's how the large language model works. Let's see one example of a large language model work. How large language models work. So imagine we wanted to create a chatbot that is like a medical GPT, where we wanted to revolutionize the healthcare department by creating personalized medicine, drug discovery, clinical trials, whatever. So that is like our end goal. And to create a medical GPT, first we need to pick foundation model. It can be any foundation model. Foundation model is nothing like a machine learning algorithm. That's it. So you take one machine learning algorithm and feed in the data. And the sources of the data in this case could be care providers, institutions, pharma companies, insurance companies, wearable sensors, just like this Apple Watch, or publication, medical forums, like, it can be a blog or something like that related to, medicine or medical industry. And the modalities can be anything. It can be image, video, graphs, tables and text, time series or sequences or genomics. The modalities can be anything. The sources can be from this particular sources. So now, team of data sourcing teams will go and get the data and process the data, which we'll understand in the coming slides, how they process and stuff like that. So they take the data and process the data and feed that to a foundation model and make that foundation model find out patterns, make those patterns into parameters or conclusions, and use those conclusions to be adapted to do all the human tasks that are needed. In this case, it can be interface for care providers, which is to help diagnose, treatments, summarization of patient records, and it can be interface for the patients to have the Q&A with the patients. It can be patients can get assertive care, patients can get the community health and prevention. So these are the few things that both doctors and patients can get from this particular model. And then it can also be used to create personalized medicine. It can use to create drugs or clinical tests. So this will be the use cases. To get AI to do all these use cases, we need a lot of data to be fed into this machine learning foundation model. So that's how LLM works, and that's one example of it. So now the next buzzword is NLP. So NLP stands for natural language processing. It helps computers understand what we are saying and respond in a way that makes sense to us, right? So, imagine you're saying apples, oranges, and eggs are healthy for humans. So this is the statement that we gave as humans. But computers or this foundation algorithms kind of don't understand this without any context. So to create context, we go to AI models and kind of say that, hey, this is a sentence related to health. So they'll just say, hey, sentence, they'll get a tag sentence called health. And they'll say, apple is a healthy fruit. And then they'll create a tag where they'll say fruits and they'll enter apple in that particular tag. They will say eggs and they'll just enter kind of food can be a tag and they'll add it. So to make computer process the data we need to do this tagging, right? So that we are structurizing the data, right? So once we structurize the data, we need to do multiple other things so that computer would understand what humans were talking, and when humans go back and ask any question, computers will be able to understand. I know this is just like a definition is what you understood, but you will not be able to understand how this process works. And for that reason, we have this, okay? So how this whole process works is it happens in like say 4 steps basically. The first step is collecting massive amount of data that is used to do all this training or pre-processing of that particular data. The second step is training or pre-processing. You can call that anything. Like few people say training, and I prefer to say it as a pre-processing, but both the same. So what we need to do is we need to do labeling. Humans label this data with language rules and teach it NLP techniques. Before we go to algorithms and feedback steps, let's just explain what happens in the training process. So we get the data and then we label the data, right? as I told, labeling is nothing but tagging and giving that particular each word a category and context. That's the labeling. Second step is embedding. Embedding is like taking all the similar words into one bucket and creating different buckets, so that it will be handy for AI to kind of search relevant words. Like all the vegetable words can be in one particular bucket, and all the fruits can be in the other bucket, or it happens like that. So with the in the massive amount of data, they will just collect all the words, and humans need to collect and make the relevant words into different buckets, so that it will be handy for AI to kind of find relevant words easier. 1, labeling. 2, embedding. 3 is tokenization. So tokenization is nothing but giving the whole word a number, right? So imagine we have 1,000 unique words in our, like, say 10,000 word article or 10,000 words worth of data that we need to pre-process. So we go to this particular AI and particular software and ask, hey, these are the 1,000 unique words, label each one of them with a unique number starting from 1 to whatever, like, requirement. In this case, if it is 1,000, it can be 1 to 1,000. So every unique word will be given as a unique number. The reason why we need to give it as a number is simple. Computers don't understand, these words. They only understand numbers. And these numbers will again be processed into 0 or 1. So it's a whole one step at a time process. So whenever we are using tokenization, we just need to convert words into numbers, so that it will be easier for computer to again convert into bits and whatever, which I don't want to go and show you. All that is super technical. Let's just understand. First, we are labeling it. And once we label each word, we're collecting similar words and keeping it in a bucket. And then we're going and asking AI to we're not asking AI, but we need to do it ourselves. But we have automated softwares that will do the tokenization these days. So once tokenization is done, that's when we use few NLP techniques. NLP techniques can be so many techniques. There are like hundreds of NLP techniques, but these 3 are pretty much common in most of the, say NLP training or large language building or whatever. So once this three steps happens, using different NLP techniques, it can be parts of speech tagging, it can be so many different things, right? So they'll use few NLP techniques and make that particular words or that particular data into a better trainable pre-processed data. That's it. And then fifth one is one-hot encoding, and the fifth one here is one-hot encoding. So one-hot encoding is nothing but converting those token numbers into vectors, and each vector having containing the digits only 0 or 1. Let me explain. So in the tokenization, if we have 1,000 unique words, we're just giving numbers like 1, 2, 3, 4, 5 to like say 980, 999 and all, something like that. But then it is difficult for a computer to convert this into kind of binary at the end. So we need to again create one more step in between where we're doing this one-hot encoding. So what is one-hot encoding? Let me explain with an example this time. So whenever we have this particular sentence, I am Avinash, in the 1,000 unique words, I can be 990 and am can be 940 and Avinash can be tagged as a name, and then it can be 100, right? So 99, so it can be 3 different digits, right? We're taking 3 different words from different buckets and making one sentence out of it. So we need to convert again this token numbers, which is 980, 990 or again 100, into vectors in one-hot encoding. What we need to do is we need to convert that token, which is 990. The token can be 001, and then the next digit, which is 990, first 980 is 001, 980 can be 1000001, and then Avinash, which is 100, can be 1010101, right? We're giving unique numbers again. So we will go to a computer program where they'll convert these tokens into different, again, numbers, but these numbers will only have 0 or 1. That's it. So essentially, we're converting these 1,000 words into different vectors, and each vector only has 0 or 1 in this series. That's it, right? I am Avinash can be like 001, 00001, and 10000000001. So all the digits in this particular series or the particular vector will only be 1 or 0. Why we are doing this is just very simple, so that it will be easier for the further in the future to convert this into ultimate units of binary into just 0 or 1 in the future. That's it. So the first one is we are labeling the data by giving tagging, and we're just taking the each tagged category and making it as a bucket in the embedding session, and then we're tokenizing it, giving every unique word with unique number from any unique number. And then once tokenization is done, that's when we are applying NLP techniques like parts of speech tagging, and they're like 100 different or 500 different NLP techniques. We're just using those NLP techniques to further process the data. So once all these things are done, that's when we do one hot encoding, which is converting the token numbers into vectors, where every single vector is just 1, 0. Every digit in that particular vector will be just 0 or 1. That's it. So this is how the pre-processing or the training happens from the data. So once this happens, that's when we insert that pre-processed data into algorithms. So this algorithm, which is again machine learning algorithm, will just process this entire information using different things, which we'll discuss in the next video, which is how ChatGPT works, or any large language model predominantly works approximately. So this algorithms will understand everything and will have a decent AI capability. That's when, after all this, humans, the feedback steps comes in. Humans train and fine tune the model with reinforcement feedback. They'll just ask like, who is Mahendra Singh Dhoni, who is Mahesh Babu, who is all these confusing questions and tough questions, so that they will just examine the algorithm and get the right answers from it. And once, if it is wrong, they'll just give the right answer by correcting it. That's all. So once the feedback is done, we'll have an ultimate product that we need that would do all those tasks that need human intervention right now, right? That's it, right? We take the data, we pre-process the data in the training step, and then we put that into algorithm, and then we do the reinforcement, and then all the tasks happen. The whole process is called natural language processing. And this process is needed to build a large language model like ChatGPT. You understand? Large language model is a final product, and the whole process that happens in the backend to build a large language model is natural language processing. Understand? Natural language processing is how we build large language models like ChatGPT or Google Bart. That's it. So that's it for this video, AI Freedom Hackers. See you in the next one. Thank you. Till then.